Like the other design principles, UML will let you model generalization and inheritance of the classes in your system. Showing inheritance is very simple in a UML class diagram. You simply connect two classes with a solid lined arrow. This indicates that two classes are connected by inheritance. The superclass is at the head of the arrow, and the subclass is at the tail. The standard way to draw inheritance into your UML diagrams is to have the arrow pointing upward. This means that the superclasses are always toward the top, and the subclasses are always toward the bottom. Think of this like a family tree drawn on paper. The younger the generation, the further down they are on the page. Older generations are typically closer to the top of the page. So, a simple inheritance in a UML diagram would have this layout. You do not need to put any of the inherited superclasses' attributes and behaviors into the subclass. The arrow is used to communicate inheritance, which implies that the subclass will have the superclass's attributes and methods. The superclasses are the generalized classes, and the subclasses are the specialized classes. Now that you know how to show inheritance in a UML class diagram, let's try to make the connection between UML and code. Let's connect the UML class diagram with the actual code. We can get some help from Doug the dog. Doug is not just a dog, Doug is also an animal. Suppose you have a dog class and an animal class. Are you able to see which class is the superclass and which one is the subclass? Is the dog class the superclass or the subclass? First, we will model the dog and animal classes in a UML diagram to show the relationship between them. We also will include the attributes and behaviors of both classes. This will show how the two classes are related to each other, how the superclass is generalized, and how the subclass is specialized. Our UML class diagram describes the dog class as a subclass and the animal class as the superclass. This means that the dog class will inherit from the animal class. The hash symbol is used to communicate that the animal's attributes are protected. In Java, a protected attribute or method can only be accessed by the encapsulating class itself, all subclasses, all classes within the same package. In Java, a package is simply a means in which the classes can be organized into a namespace that represents those classes. We know that a subclass will have all attributes and behaviors of the superclass that it inherits from. So we do not need to put the superclass's attributes and behaviors in the subclass in our UML diagram. This is because the inheritance notation tells us that the subclass will already have the attributes and behaviors listed in the superclass. Now, let's convert the UML model into code for the animal and dog classes, so that we can create Doug from it. Since an animal is a generalization of specific species, we do not want to be able to create an animal object on its own. We use the keyword abstract to declare that this class cannot be instantiated. That means that we cannot create an animal object. The animal class will be the superclass for our dog subclass. Any class that inherits from the animal class will have its attributes and behaviors. This means that if we were to introduce a cat subclass into our system that inherited from the animal class, the cat and dog subclasses would both have the same attributes and behaviors as the animal superclass. As you would expect, we do not need to declare any of the attributes and behaviors that the dog class inherits from the animal class. Notice that our code and UML diagram are similar in terms of what attributes and methods are declared in the superclass and subclass. The UML class diagram represents our design. If we do not need to restate the inherited attributes and behaviors in the code, then we also do not need to do it in our UML diagram. We declare inheritance in Java using the keyword extends. You instantiate objects from a class by using constructors. With inheritance, if you want an instance of a subclass, you need to give the superclass a chance to prepare the attributes for the object appropriately. Classes can have implicit constructors or explicit constructors. In this implementation of the animal class, we have an implicit constructor since we have not written our own constructor. All attributes are assigned 0 or null when using the default constructor. The animal class in this implementation has an explicit constructor that will let us instantiate an animal with however many legs we want. Explicit constructors are used so that we can assign values to attributes during instantiation. A subclass's constructor must call its superclass's constructor if the superclass has an explicit constructor. This is because explicit constructors of the superclass must be referenced by the subclass, otherwise the superclass attributes would not be appropriately initialized. In order to access the superclass's attributes, methods, and constructors, the subclass uses the keyword called super. Subclasses can override the methods of its superclass. meaning that a subclass can provide its own implementation for an inherited superclass's method. The dog class has overwritten the animal class's walk method. If we were to ask the dog to walk, it would tell us that it would rather lay on the couch instead of performing the behavior implemented in the animal class. Now that we've seen how to represent generalization and inheritance in UML, and how to translate UML class diagrams to code, and the similarities between the two, let's shift gears and explore the different types of inheritance. The inheritance that we have been looking at is called implementation inheritance. For Java, only single implementation inheritance is allowed. While a superclass can have multiple subclasses, a subclass can only inherit from one superclass. For example, the dog and cat subclasses can each only have implementation inheritance with one superclass, which is animal. The animal superclass, however, can have any number of subclasses, 2 in this example. To implement this in code, we simply have the cat and dog classes extend the animal class. Now we have a cat and a dog that behave like an animal without having to explicitly write code for them. They also have their own behaviors. Doug would know how to play fetch, but would not know how to play with yarn like Mittens would. In this way, we can create specialized classes, like the dog and cat subclasses, with customized or special behaviors. Note that a subclass itself can be a superclass to another class. Inheritance can trickle down through as many classes as you want. Inheritance will let you generalize related classes into a single superclass and still allow the subclasses to retain the same set of attributes and behaviors. This will help remove redundancy in your code and make it easier to implement changes.